So hello friends, welcome to my YouTube channel. So today's topic is HPA. Okay, what HPA is? HPA is horizontal pod auto scaling. Okay, so uh, I will first uh, clone the repository. Okay, so this is my Kubernetes repository. Okay, I need to have the git clone, git software for this. Install git hyphen y. Okay, so I am just cloning the uh, one GitHub repository that is of Kubernetes into this server. Okay, so for that, to use that any git command over on this EC2 instance, we should have the git software first. Okay, so I have installed that software just now. Okay, so now you can run that git clone. Okay, so we have cloned the Kubernetes repository in this server. Okay, so if you check ls-lrth, you will be getting this Kubernetes directory over here. Okay, so go to this rth and our is day 4, right? cd day 4 horizontal auto scaling. Okay, so there are three files. Okay, so see, in here we will have this horizontal auto scaling. Okay, where it is horizontal auto scaling. This is okay. So this is our deployment.yaml file. Okay, we have already seen this. Okay, so we have already seen this that there is a API version v1 kind is deployment metadata uh, gives the name of this deployment, right? And specification we specify the replicas and selectors. Okay, we have seen this. Okay, so what new is here is if you see this container image here already seen that we are importing the nginx image from the uh, Docker registry. Okay, and then here is the new block. Okay, so what this resources block is here. So here resource block we are giving some control on the pods. Okay, so pods will take resources, right? The CPU and RAM. Okay, so that information. Okay, so from where it will take though that hardware, so it will take from the node. Okay, node on which our pod will be deployed. Okay, so we have already seen that there are two worker nodes. Okay, by default there will be two worker nodes when we have created the EKS cluster. Okay, so I have already started the running the EKS cluster, and it is running because it will take some 15 minutes. Okay, so I have already scheduled that. Okay, so here in the resource bar we can see that we are requesting this CPU of 250 millicore. Okay, so what this means is that we are requesting the node, the worker node, that please allocate me 250 millicore at least for this pod to be get deployed. For that pod will be having RAM and CPU. Okay, so I am requesting CPU of 250 millicore from the node. Okay, so resources in the resources section. Okay, so request. Okay, so request is the minimum amount of resources required for the container to start. Okay, CPU, the requested CPU here is 250 millicore, and the memory, the required memory is okay. One more section is there, that is limit. Okay, so the in that the limit is maximum amount of resources the container is allowed to use. Okay, so the CPU limit and the memory limit. Okay, so uh, this is the deployment.yaml file. Okay, so then we will see the horizontal pod autoscaler. So see, this is the HPA, horizontal pod autoscaling. So what is the need of this? Okay, so if you see the our replica set, okay. So in the replica set, there is the replica count we have to give. Let's say if you have given the three count there, but that three count is the static one. Okay, so irrespective of your utilization of the pod, okay, whether it is high or whether it is low in the lean traffic period, it will remain be three pod always. So that is the static count over there we are giving in the replica set. Okay, so uh, but that is not recommended, right? So when you have the when you have the high utilization, but your pod remains three, so that time maybe there is a pod requirement of five, but we are catering only three. Then that is the revenue loss, right? So similarly, if you have minimum traffic in the night hours, then there is no need of specifying three replicas over there. Okay, so that is static count. It is not recommended, right? Because in night hours there will be a CPU, there will be a underutilization, right? So those resources will be a waste of costing, right? So for these, this concept comes into existence, that is horizontal auto scaling. Okay, horizontal pod scaling. So what it does is it it is like a auto scaling concept. Okay, so based on your CPU utilization, your pod count will be increase or decrease. So based on the load, okay, so based on the load, it will take the decision to increase or decrease the pod count. Okay, so if you see these three lines, okay, API version, kind, and metadata. Okay, so kind we already know that we will be giving horizontal pod autoscaler. API version is this is auto scaling, so we are giving here auto scaling. Okay, sorry. Okay, so okay. So, and metadata is the name of the HPA, right? And the specification, okay. So this specification we are giving in the scale target reference, okay. So we are giving here the deployment.yaml file, right? So this is the deployment.yaml section, okay. So we are giving the here so this spa.yaml has to target your deployment.yaml, okay? Because deployment.yaml will deploy your pods on the nodes, okay? So definitely here target should be your deployment file, and we can see this in the scale target reference section, right? So what here given is that this is the deployment file, okay? And this is you can see that minimum replicas we are giving one and maximum replicas 10. Okay, and in the metric section, we can see that there is a resource. We have already seen this resource and resource and name and CPU and target utilization. See average utilization. So we are telling the cluster that whenever my pod application utilization, uh, the average utilization crosses one, then you need to increase the maximum replica till 10 based on the this condition because we are giving here the CPU utilization condition of average utilization of 1. So based on this load, this pod count, okay, pod replicas that will be created. So if the load is less, then it will be remain 1, okay, and if the load is greater, then it will be up to 10. Okay, so similarly, this will take care of this load utilization of the pod. Okay, so we can see this in the form of paint if we required. Okay, so this is the spa.ml, and then there is a service. So service we have already seen that we are using here the load balancer service. Okay, so rest of all the things are we have already seen in the last lecture, right? So these are the same. Okay. And so if we, okay, let's understand it from the paint. Okay, MS Paint. Okay, Okay, sorry. Okay, so we'll compare all these means how is the relation between these three files, okay, deploy.ml, hpa.ml and the service.ml. Okay, so if we take hpa.ml, okay, we will see the relation between these files. Okay, so just copy. Okay, now it is open. Okay, so this is our hpa.ml, right? Okay, then we have our uh, deployment.ml, right? Okay, so this is our deployment.yaml. Just copy this. Okay, so and the third one is our service, right? Copy. Okay, so this is HPA, horizontal pod autoscaler. This is deployment, and this is service. Okay, so if you see this target scale target reference, okay, so this okay, so this section, right? This section defines the deployment. So it is targeting this deployment file. Okay, so if you compare this section with this one, okay, so if you see, okay, it is exactly same, right? So there is a relation between this and this. So this HPA is targeting the deployment file with this scale target reference section, right? The API version apps v1, API version apps v1, the kind is deployment metadata is nginx HPA. Okay, so this is the communication between the HPA and the deployment. Okay, and then we are already seeing that this match this selector, right? So match labels. Oh, sorry. So this match labels, right? This is selecting the this service, right? This service is selecting the app nginx, right here. So this service is selecting the deployment. Okay, so here. So this is the relation. Okay, right? So HPA will call the deployment and take the relation between these two with respect to this section. And the deployment.ml will be selected by the service based on the matching labels, right? This app nginx and this app nginx mentioned in the deployment file. Okay, so let's see our practical now, right? Okay, so just check whether our cluster is created or not. Yes, our cluster is created and it is hanged also. Okay, I will refresh it. Okay, or better it is. Okay, so we have already clone the respective directory over here. Okay, so just check what are the files are there. We can see that this deploy.ml, HPA and service and test. Okay, so So test.sh, right? This test pods, right? kubectl apply hyphen f and dot. Dot means it will take all the directories over here, all the YAML files it will take, okay, in one go. Okay, so execute. Okay, sorry, this mistake. First, we'll check whether our node has been created or not. Sudo su hyphen kubectl get nodes. Okay, so both the nodes are worker nodes are created. We can execute this command for the deployment. Okay, so we can see that deployment is created, HPA is also created, and service is also created. Okay, so just check the pods where whether it is got created or not. Get pods. Okay, so one pod is created. Okay, and it is running. Okay, and let's check whether our HPA got created or not. kubectl get HPA. Okay, so it is also created. And here you can see that minimum pods is 1, maximum pod is 10 because we have given this configuration in that file, right? In the HPA file that minimum replicas is 1 and maximum replicas is 10. And replicas count we have it is fetching from the deployment.yaml file, okay? And here is the target, right? We have given the CPU as a target to track the its utilization, right? Uh, Currently it is showing as unknown, right? So for this so this HPA has to track the CPU utilization. Okay, so CPU is a metric, right? So we need here the metric CPU metric installation for this to so that it will fetch the required load from the metric server. Okay, so just check. I have already in a handy this metric server deployment. Okay, so this kubectl apply. Okay, if you can see, this is the GitHub URL for from which it will execute the download the metric server. Okay, and so these are the commands. Okay, so deployment metric server hyphen n means this is the namespace in which kube system is the namespace in which this there will be a metric server deployed. Okay, so from this namespace we have to query that deployment server whether it is created or not. And top command is to see the pod load and the node load. Okay, so these are the commands. So try to execute it. So let's create the metric server. So it is creating. Okay, I think we need to some error is coming now, so we need to update our context, I guess. So where is the command? Right here, or where it is? Maybe down the line. Control H, control home, control home, control context. So here it is, update kube config. Okay, cluster name is test. So my EKS cluster is updated. Now try to run the command. Okay, so we can see that these are getting created. Okay, metric server unchanged. Okay, metric server already deployed. Okay, so check whether we are able to metric server control home. Yeah, this is. So just check whether this metric server is created or not. Okay, it is created, but we should see some more files over there. Six server releases latest. Mm-hmm. Okay, try to execute it in root. Okay, it is already running. Be up to date. Okay, so whenever I am running this kubectl get deployment metric server, that time I am only seeing one metric server. Okay, kubectl top pod. Let's see kubectl top pod. Okay, metrics API is not available. Mm-hmm. What about kubectl get HPA? Okay, but still it is unknown only. Mm, it should come, it should show the here the uh, CPU percentage. Okay, that is the main motto here. Let me check kubectl so now process data in your cluster is deployed by default. Deploy the following process, deploy the following command. Number of pods with the following command. Mm-hmm. Okay, it is. I think it is right, but not sure why it is missing the kubectl kubernetes IO latest notation which is required by kubectl. Should only be used on the resources created declared by either kubectl create. The missing annotation will be patched automatically if the server is unchanged. The deployment metric server is invalid, immutable. Okay, but whenever we are running here, hyphen cube system, it is showing me metric server is actually there are multiple server is also downloaded with this that, that is not getting here. Okay, so how can we see then? The load increase, right? It is unknown here only. Mm-hmm. CD day 4, day 4, horizontal. That is okay, but uh, it should run multiple servers over here. Metric server, metric server reader. Okay. kubectl describe npa ngnx. Okay. Sorry, hpa. Okay, so you can see that failed to get a resource metric, failed to get a simulation, unable to get metrics. So CPU no metrics return. Okay. Failed to get CPU and did not receive metrics for. Okay, some error is coming. That is why we are not getting the CPU load over there. Okay. We'll do one thing. We'll try to run that test script. Okay, in which we will uh, check the load balancer URL whether it is coming or not. kubectl get svc-o wide, right? So this is the load balancer URL. Okay, check whether we are able to access it or not. Okay, okay, so we are able to access the Nginx application. Okay, so copy this URL and sorry, give it into the that test.sh. Okay, so here we are hitting this okay, so it is increasing the load. Open the another node and check the kubectl get hpa. Okay, but kubectl whether the pod has increased or get pods. Okay, so still it is one only. Okay, I'm not sure it is running or not. Okay, I think it is hanged. Okay, so it is in only one pod is there. Okay, okay, sh dot SSH. But we are unable to see the CPU load. kubectl get HPA is unknown. Why it is not able to the kubernetes matrix? It is already. So these are the metric servers, okay, metric servers. But somehow I am not able to see those kubectl. kubectl get top pod. Sorry, top pod. Matrix API is not available. Actually, our metrics server is not installed. That is the reason. Hmm. Okay. kubectl. We will check the latest one from the internet. kubectl metric server, right? kubectl delete metric server. I'm not sure whether it is delete metric server. Okay, so we have deleted. Just check on the chat GPT whether we are getting the metric server definition. GPT. Metric server metric server deploy file for HPA. Oh, metric server deployment with HPA. Okay, so this is the official metric server manifest. It is the same, right? Deployment metric server happen in kube system. I'm not sure why it is giving us the download component.ml. It is the same command, right? Let's see whether it is. Okay, so I think it is currently executed now. Just check now the whether it is query the deployment of the metric server. Oh, unfortunately, this I need to run. Earlier there was some error was coming, right? Okay, but still only that server is. Mm-hmm. Metric server. Okay, now check whether we can get the load of the pod. Okay, still that error is there at kubectl pod, right? Mm, so actually in that no top it will show the CPU and the memory usage, okay, of the pod. But I'm not sure why it is not getting executed here, although we have tried from the official website. Mhm. Okay, I will check for this. Okay. Meanwhile, I will check for this and come back with this metric server. Uh, but it should be installed there only. I'm not sure why it is getting because I have copied it from the official website only. So, okay, anyways, uh, we will focus on now the another concept that is called the namespace. Okay, so namespace. Okay, so why we use the namespace concept in the Kubernetes? Okay, so there are let's say multiple clusters. Okay, so there are multiple teams, right, in your organization. Let's say one development team, one testing team, uh, one production team, right? So there is a separate team, and those and one functional testing also, right? So those teams will be having their separate clusters. Okay, so if you deploy your any of the file, okay, so it will be deployed in the default cluster, right? But every team, if we try to deploy it by default, then it will be mess, right? So all the cluster will be all the teams clusters will be deployed in the